I've covered most of the material in the first 3 chapters, even 4 and 5. So please read 1 through 5, and I'm going to go through 1, 2, and 3 today. From chapter 1, you can expect mostly definitions on the test. There's not much more to it actually. The idea of algorithms, programs, programmer, things like that. So I'll go through it rather quickly. Okay. You know there are several steps in solving a problem. First you got to identify the, I wrote IPO on the board a few days back. Input, processing, and output. So you got to identify the input. The goal, of course, is what should be the output, objective of the program. So that's this. And in between, you've got to do the processing, or those are the tasks. Okay? So do you have any questions on these? They're somewhat vague. The definition is not very precise. But we'll see an example or two. Okay? So in this example, which I covered last time, I did a flowchart and a program on Thursday, I believe. You're given the distance traveled, that's this 1224 miles. The car gives you so many miles per gallon, so that's given information. And the cost per gallon is given. You're supposed to calculate the cost, total cost of the trip, okay? So the objective is to calculate the cost or goal. And the input is these 3 numbers, okay? And the processing is done with this formula. Okay, so identifying the input, there are 3 of them right here. There's not much to discuss here. And the goal is to find the total cost, right? So how do you do that? By plugging in the inputs into the given equation and then returning or printing out the cost, same thing. If you write a function, you would return the cost, okay? But we are not going to discuss functions for a while. Towards the end of the course, we'll have functions. So what tasks do you need to execute to reach the goal? You got to do this calculation basically. And the cost turns out to be this. And I stressed before that you got to write flexible programs which should work on not just this input, but any input. Okay? The flowchart and the Python program should work on no matter what you have for the input. This sort of a second step was to see the tasks are the third step, the goal is the second step, input is the first step, right? So don't depend on that. I'll ask you clearly what's involved in the tasks or something more specific, okay? I'll skip over the self-check exercises, and again, this assignment is from the book, so please read that material and answer the questions. So there are 3 definitions here. A programmer is a person who solves the problem, creates the programs. A program is a sequence of steps, right, to solve the problem. So the programmer comes up with the program. And the language it's written in and given to the computer to execute is the programming language. Okay, any questions on these definitions? Okay, chapter 1 is very simple, so I'm rushing through it so I can spend more time on 2 and 3. Once again, there are a few more definitions here, 4 more. A computer is just a device which does calculations. Algorithm is set of instructions. Now you might ask me what's the difference between an algorithm and a program. Okay? Algorithm is a sequence of steps on paper only. It doesn't have to communicate with a computer. A program does have to communicate with a computer. A program is therefore more precise. It's the implementation of the algorithm. Okay? Any questions on that? Okay. So a bug is just an error in the program, which of course you should try and remove most bugs, if not all. For a large program, it's not possible to remove all bugs actually. It's well known in computer science that for every 1,000 lines of code program, you have at least one error in the program, usually. If you try and remove that, you introduce something else. Very hard to have a bug-free, totally bug-free program if it's large. If it's small, 10 lines long, whatever, then you should be able to remove all the bugs. Does anyone know how many bugs Windows XP had when it came out? Approximately 65,000 or so. I think they ran out of a 2-byte number, so it may have been more. I'm just joking actually. So debugging is the process of removing these bugs, and that's what you're learning in this class, right? To debug programs, write programs. First, therefore, you should come up with an algorithm before you write the program. We'll study pseudocode and flowcharts in more detail for the algorithm. Any questions so far? Okay, so I'll skip the conclusion. It's basically a summary of that chapter. These exercises at the end of the chapter, please try and do those, but don't submit them. You're not required to do all of that in addition to the homework. I just give you the bare minimum homework. And then again, don't worry about going to this particular website and trying the quiz. It may or may not work. It's somewhat old already. And those are multiple choice questions or true-false questions. They're not going to give you enough practice to prepare you for the test. Okay?
So we don't have to do the quiz?
These quizzes you don't have to do. Okay? But you should, what I'm suggesting is, at the end of the chapter, you should try and do as many of the exercises as possible. Does it say that there are a whole bunch of them? Here, these. Now some of those are English-like. How do you do certain thing using, simple logic, walking around, driving a car, this, that. So they're not very precise. So you don't have to do them. The basic thing is, in chapters 2 and 3, we are coming to those. It's much more important to those. For example, homework 2 and 1. Okay, so let's go on. I assume there are no more questions on this chapter, but let's go on to 2. Okay. Pick up with this slide. These are again some definitions. Data is simply either strings or numbers for us so far. Okay, it could be other things like pictures, soundtrack, etc. But we are dealing basically with 2 types of data, strings and numbers. Numbers themselves can be of 2 types, integers or real numbers, floating point numbers. So data type is the type of data you want to store. And again, string variables contain string data type and so on. This will become more precise, and I've already given you a couple of programs to work with. Hopefully that has become clearer. In fact, how do you get that printed out in Python? Very briefly, I'll remind you in code samples. Here, type. I believe that's the one. So even though this is an older version of Python, it may not run because that version is different, right? But this tells you that the type of A is, let's run it, a real number, and this tells you it's an integer for B, and you can change the type. In Python, you can change the type from a number to a string or anything to anything, okay, later on. So this should be a string, str. Let's run it in. I clicked on the wrong thing. Okay, see, type is float for A, integer for B, and str for A again. So you can change the type. In very few languages can you do that. In Java, you declare something to be of type integer or real or string. Not any combination of any of those. You can't change the type. So please try and understand this along with what we are discussing in this chapter. Okay. So that's what we are referring to, type of data. Character is actually just one letter out of a string. Okay. So usually we put in single quotes. For example, H. Don't count the quotes. This is a character or string of length 1. We don't have characters of length 0, for example, but strings can be of length 0. It's called a null string. Okay. Any questions so far? Okay, let's keep going. Now, inside a computer, strings or characters are coded, at least on small computers, personal computers. They used to be coded in ASCII, now they're mostly Unicode. This table doesn't show you anything of meaning, but suppose I type in the character A. Then internally it's represented with this decimal number 65, okay? And ASCII, I may not be precise, but it's something like this, in 8 bits. Let me make 8 bits out of this. Okay. It turns out to be 0, 1, 0, 0, 0, 0, 0, 1. That's 64 plus 1, 65, okay? Now that's in binary. Now you're not responsible for learning all these codes. I think you learn much more about ASCII and other coding methods in 242, the computer architecture class. This is just a beginning programming class. So each character is of course unique, right? A decimal code is unique for that. B, capital B, for example, small a will be totally different. Capital B will be 66, the next number. Small a is 65 plus 128. For whatever reason, this bit is also turned on. Okay? So in ASCII, you can have only 0 to 255, the range of numbers. But there are many more characters in natural languages, right? You got Greek and Latin and so on and so forth. So they went to Unicode where they doubled the size, 2 bytes. And therefore they can accommodate roughly 65,000 characters, okay? So word processors are much simpler if they use Unicode. They can do word processing in many languages all at once. And even then there are plenty left over, about half of these are left over. So you're not responsible for Unicode either. But you should know that inside a computer, since we have only zeros and ones, you're restricted to converting characters to numbers, right? Any questions on that? Okay. So as a quick example, this is a string. If you want, you can put double quotes around it or even single quotes. Python accepts either one, but we are using single quotes for single letters or characters and double quotes for strings inside the book. So a blank space counts as a character. So there's one here, and so on. So the length of this is 48 apparently. You can check it. Any questions on that? So now we've studied 4 types of data type, right? Character, string, integers, and floats. Floats are real numbers. Okay, coming back to numbers, these are whole numbers, right? All 3 of these. So these are called integers, positive or negative. But floating point or real values include a decimal point. And their representation is totally different inside a computer. There's no relationship between how you represent these as opposed to strings or characters. Okay? And once again, 242 is the right place to learn much more detail about these. Any questions though? How about fractions like 1/3? That will be a real number. Okay? Now, to manipulate these numbers, you need operators. And what are operands? Well, we'll come to that example. Operands are the data you manipulate with the operators. So let's take, for example, this calculation. -4 is one number, -16 is the other number, and this is the operator, plus. And each one is called an addend if you're doing addition. And therefore, this gives you -20, right? You can read the rules. If it's the same sign, then you have the same sign in the result, right? If you have different signs, like in this example, you get the one with the larger number is responsible for the sign. Any questions on that? This is all review, right? In math and high school, etc., you've seen all this. But the main thing to remember is the definition of addend, operator, and operands. So we'll see more operands and we'll see more operators in a minute. This is the simplest one. The plus sign is the simplest one. Okay, subtraction is really addition if you think about it. This is the same as this, isn't it? So that gives you +6. Again, this could be considered an operator, operand. One is called the subtrahend, and I don't remember the name for the other. Does anyone recall? Those are not important at all. We just treat all of them as operators or operands. Okay? Now, there are 4 types of multiplicative operators. The simplest being multiplication. For example, this gives you 21, right? You multiply the 2 out. Now, it happens to be a shortcut for addition. You add 4.25 times and you get the same result. So this yet another operator. And we look at 3 other multiplicative operators in a minute. Any questions on this? Okay, this is all very simple. Division is next. For example, this gives you 3.4. Now, I'm not going to ask you on a test what is 6.8 divided by 2.3 or something. That will take a long time to do. And I usually don't allow calculators of any type. Okay, computers are turned off. I mean, it's an essay type question with no calculators. Okay. So divisor and dividend. The top number is the dividend and divisor is this. These are very important, integer division, and we are coming to mod in a minute, the remainder obtained. So this gives you 3, you drop the fraction, that's all. Okay. If it was 7/2, you still get 3, right? So most of the time, I'll just ask you to do integer division on 2 integers most of the time. Now, Python is not limited to that. It can figure out 6.8/2.3 and give you the result. But the result is always going to be a whole number or an integer. Okay, any question on that? Okay. And I will not ask you tricky questions. For example, what happens if there's a -2 or -6.8, etc. You can ignore all that because there's sometimes many rules associated with each operator. So don't worry about all those. Okay, mod or modulus. Let's take this example first. 7% 2. This is the dividend, this is the divisor, and this gives you the remainder obtained after dividing this by this, and it's again a whole number. So 7% 2 gives you a 1, right? 7//2 will give you a 3. So this difference is very important. Please try and remember that. I've asked you some of that on homework too, and it will show up on the tests also. So get plenty of practice by doing as many problems from chapter 2 as possible. Okay? But don't submit anything else except what's required for the homework. Any questions on that? So we've gone through 4 different multiplicative operators, right? The star, slash, //, and %sign. Now we've used the same terminology as Python, but in Visual Logic, I remember telling you that // in Visual Logic versus Python is backslash, and percent in Python is the same as mod. Capital or lowercase doesn't matter, with blanks around it. Okay. Any questions on that? And that's in the documentation for Visual Logic on the Y drive. Which I'll explain one more time because a couple of you just added the class, so maybe you missed that. Let me do that right now before I forget. I forget very quickly. Okay, so I mentioned that I always put the assignments under that folder. Look at those. And I also put it on Moodle if I remember. So code samples is important. You have to run all these programs. The only one which is complicated, which I will not discuss in class, is example 4a. Okay? It's apparently something to do with the graphical user interface. And that's too much for this class. So course information is the syllabus, and this contains a whole bunch of useful things. This is the Visual Logic program. I have not discussed Raptor, but if you want to use that, that's fine with me. I prefer Visual Logic. It's cleaner, less complicated actually. And Raptor is free. It's a flowcharting program where you can save the flowchart. Visual Logic you can't unless you pay $49 or whatever to buy that key. The syllabus is important. This is for your own good. If you want, you can compare or see how Visual Logic and Python is used. I don't know why we have 2 copies of this. Anyway, Visual Logic user guide is very important, and this is the free book which we're using in this class. So out of these, all 3 of these are useful. Dropbox, do not submit anything through that. External link, instructor only. Lecture videos, totally unnecessary. PowerPoint is the only other useful thing. And it contains the 12 chapters slides. Please copy them to a memory stick or something. Now I'm going to do chapter 3 also today. They're all very simple. Hopefully we can handle that. Okay, so let's continue with this. Again, difficulties arise if any of them have a sign. Okay, so I would not worry about that. There are a whole bunch of rules if you have a sign. Now please note the difference between these two. This gives you a whole number, right? The result is 2. whereas this includes the fraction, and that's the answer. Any questions on that? And then again, you'll see plenty of examples in the exercises. So this also very important. If you see combination of these operators, what do you do in one line? Then you normally evaluate left to right, okay? But multiplication, all these are done with higher priority. They should be done before the addition and subtraction. So we'll come to that example in a minute. Unary minus means there's only one thing after the minus sign, nothing before the minus sign. And parentheses change the order of evaluation, as you know. So I'm anxious to get to the example. Or unary minus is briefly defined as an operator which has only one operand, and this is an example. All the others are binary operators because they have two things, two operands to work with. Any questions on that? Okay. This example is very useful, and I can do more if necessary, but let's not worry about it. Let's focus on this first. If you're asked to evaluate this or solve this equation, I mean not equation, but expression, you normally go left to right. But can I do 5 plus 4 now? No, because this is higher priority, right? The division is higher priority. So you do that first and you get it 2. Now, continuing further, can I do multiplication next? No, because of parentheses, we need to do this inside part first. And parentheses can be nested or put inside of other parentheses. So 3% 2 gives you a 1, right? Now, the simplified expression is 5 plus 2 minus 6 times 1. So this has higher priority than the others, right? So you're going to get 6 here. And this simplified to this now. These two are the same priority. Go back to that table. So I do the left one first, get 7 here, minus 6, the end result is 1, okay? So I want to see charts like this for all the expressions which are more than 2. I mean, just one operator, you don't have to worry about making a chart. It's obvious what needs to be done, but for anything like this, make a chart like this. Let me do this without the parentheses, okay? Just to show you the difference on the board. So let me see if I can get it right. Okay. /2 will make that, well, it makes no difference in this case. I was going to make that //. I'll leave it up to you to practice. You have to practice a little bit. Okay, may I have your attention, please? You can do your homework a bit later. Petruska, can we do the homework a little bit later so you can focus on this and not disturb the class? Okay, minus 6, and I'm going to change this to without the parentheses, right? Is it 3% too? Now, if you're doing it by hand, you can do this, 2.0, to be more precise. This gives you a real number, right? And then, because there are no parentheses, this has the same priority as that, so you get 18. Okay. So if you want, you can write this again, but what comes next? The percent, right? Okay. So that gives you a 0. Remainder obtained after dividing 18 with 2. And then you can go left to right because plus and minus have the same priority, right? So this 7.0 or 7, it doesn't matter if you write just 7. And then finally, that gives you we subtract 0 from 7, we get that. Any questions on that? Now, I hope I have not made a mistake, but you should always double check your answer, okay? Any questions? No questions? Okay.
I've got a question. I've always learned the term PEMDAS, parentheses, exponentials, then division, multiplication, addition, subtraction. When you do the 3% 2, isn't that kind of a division?
Yes.
Shouldn't you have done the division first?
It's the same priority as the multiplication, right? So I did the multiplication first.
Multiplication and division, yeah, you're right.
Now, if I put the parentheses here, then you're right.
Okay, yeah.
Okay? That's I'm comparing the two, what's done on this and the board. Now, we are coming to exponentiation. We don't have it yet, but we are coming to that. Any other question? Okay, I don't remember that name, by the way, but if you do, then just be careful, because sometimes there could be small differences between what you learned earlier and this. So for exponentiation, we use this caret symbol. Now, Python doesn't use that. Visual Logic does. So 3 squared, Python, we would use this, 2 asterisks. Okay? And Visual Logic does use the caret, same thing. Now, okay, very simple to understand. This means multiply 3 with 3 like this, okay? Total of 2 times, including itself. So 3 squared is 9, right? So that's easy. And anything to the power 0 is always 1. That's the basic definition. Okay. So this is called the exponent. And I will not ask you what is 3 to the power 2.5, for example. Okay? That will take forever to figure out unless you have a calculator. But 3 cubed, yes. 3 to the power 4, yes. All that, yes. So the other caution is it's done right to left. Very important. So if we write if you see 3 to the power 2 to the power 3, in algebra it's 3 to the power 2 to the power 3, and it's done right to left. Or to simplify it, you can imagine, or you can put parentheses like that. So 2 cubed is 8, 3 to the power 8, you should be able to evaluate 3 times 3, 9, etc. But that will take a long time. But it turns out to be different from this. It may have a different result. I'm not sure if that's true for this example, but I'm warning you that it does not work out symmetrically. Okay? So the modified table is like this. Always do the parentheses, then the exponentiation, then unary minus, and then type conversion. This we've not discussed, which I'll discuss right now in a minute. Then come the multiplicative symbols, then addition and subtraction. Type conversion, okay. It's also called casting or cast. So if I say take the integer of 3.5 and then multiply it by 2, I have to do this first. It's a unary operation which says take what's beyond that and work on that with this first. Okay, so we get a 3 multiplied with 2, that gives you a 6. Okay. Let's see the definition first. There's no definition here, but you could have two of these in a row. Float, for example, convert to real, that is. And this informal, you don't use this. Suppose I had this. Then I'm not going to get 8.5. I have to do this first, right? According to this table, that's higher priority. And then the addition or multiplication. So that gives you 3.0, or 3 actually, because it's an integer. And float of that is going to give you 3.0, add 5, that's going to give you 8.0. Now, we can't use it like that in Python either, unfortunately. Okay? We use it slightly differently. You can say int of something, float of something, like that. We put the parentheses around that. That's the only difference. But in the book we use this because in some computer languages you use this technique in the book. Okay? Now for algorithms it makes no difference as long as you understand what happens. For example, okay, here's another good example. Convert this number into a character and you get a B. If I had convert B in single quotes into an integer, I would get 66. Okay? Yes?
What does the unary right to left mean?
Unary right to left is also the same. Suppose I had minus 5. Then you interpret that as minus 5 first, minus 5 next, like that. It may not make much sense in this example, but it's done right to left because how else do you evaluate unary? So the first 3 here are right to left, and these are left to right. Okay? You just have to remember this table as far as this book and algorithms are concerned. Now, for different languages, unfortunately, things are different sometimes. In Python, it's more or less exact. I think it's almost the same. I've not come across any examples where it's different. Okay? And of course, in Python, you use 2 stars here instead of this. Any other questions? Okay. Again, I'll skip this. But you can read it and see if you have any questions. Let's go on to, so it's more important to do the exercise at the end of this chapter, but again turn in only the homework, number 2. Let me get to the next chapter. Okay. Now, I've already demonstrated most of this by example, so I should be able to go through this quite rapidly. Is sequential order important? Don't you do things in sequence, driving, etc., putting on socks and shoes, etc., in a sequence? So this typically what's done in this country, right, in English, top to bottom, left to right. Now in Japanese, etc., I'll stay away from all those examples. In Arabic, you go right to left, etc. But in programming and in English, we go top to bottom, left to right. So this is an assignment statement where you take the number 3, put it in the variable called A. And we think of it as follows. You think of A as, before I've done this statement in Python, I don't know the value of A. After I've done this, then the value of A is 3. I fill that cell. This is called a location or a cell. Or the value of the variable is 3. So this is obvious, right? We always read programs. I've given you so many examples already top to bottom, left to right. Okay, pseudocode is how we write an algorithm. Now that's not the only way. You can use flowcharts also. Pseudocode has start at the top and end at the bottom, just to indicate the boundary of the algorithm. We'll see some examples, I hope, in a few minutes. So I'm skipping the details right now. In flowcharts, we use these symbols. This for input output. This for assignment statements. This for start and stop, start end, and arrows to connect the boxes together. So I've given you so many examples that it's not worth discussing any more details. So in Python, of course, it's a programming language, fairly modern one. It's 10 to 15 years old, and I like it. I got 120 going with Python. It used to be in Java quite a long time ago, about more than 5 years ago. So let's focus on dependency. This is more important. Sequential order, of course, we know already. We'll discuss that with an example, and we can always come back to the definition. So suppose you want to calculate and print the average of these three numbers. First, we identify the input, and for the time being, input and assignment statements have been, unfortunately, we are using assignment statements instead of input, whereas we should actually use get statements. We're coming to the chapter beyond, so excuse us for that because we've not discussed input-output so far, okay? Then you got to identify the objective, which is to figure out the average and print it out. Input and output. And then the equation, of course, is take the sum first and then divide by 3 in this case. Okay, so this is almost like pseudocode. Assign values for the input, calculate the sum, calculate the average, print the average. So does this depend on calculating the average first? Yes. So that's roughly dependent. Does calculating the average depend on calculating the sum? Yes. So this will be more precise as soon as we look at the pseudocode for that. This is a start, end, that's the algorithm. And for the time being, we are not using input statements for these three, but we should to make the program general. So num1 is one variable, is given the value 5. Calculate the right side, it can be an expression, more complex thing than just a number. Put 10 in this cell, put 15 in num3. And why are they different? Because otherwise, if I use num1 here, the 5 would be lost, okay? It overwrites what's in the cell. And then calculate the sum, calculate the average, print the average. So what are the dependencies? Now sum depends on knowing the values of these three. So you got to do these three before this statement. That's one dependency. But are these dependent on each other? No. They can be done in any order. Okay? This has to be done after this, after you calculate the sum, because on the right side you use the value of sum. And this has to be done after this, so that's another dependency. This depends on that, this depends on that, and this depends on having values for all three. So there are three dependencies here. Any questions on that? Okay, we are almost, well, halfway done with this. Flowchart is pretty obvious. You have start and stop. We are using the same boxes as mentioned earlier. Where are they? These and the arrows. Now, I've given you examples of structured flowcharts. So I'm going to use those occasionally. Well, remind me to use them more often. They're almost the same as pseudocode. For example, this will be structured flowchart. you got to read handout 1, 2, and 3. I may or may not cover all of them. I'll try and cover some of it. So, structured flowchart is nothing but you have boxes like this, and you can use this back arrow for an assignment, or you can use num1 equals 5, same thing. I prefer the back arrow, it's clearer. Assignment is right to left. And you can number the boxes. So the rest will be exactly the same as the pseudocode, so I'm not going to redraw it. And remind me to do some of those handouts later on. So any questions on the flowchart? Again, we should replace these 3 with these shape boxes for input only. 3 of them for input, and then calculation and so on. Any questions on that? Okay. And this is the Python program. Of course, this is a comment. Comments start with £. This became too long. It should have continued here. So this program won't run if I try and run it. To try and figure out what this statement is won't make any sense. Any questions on this? Okay. Almost done. So coming to dependencies again, what's wrong with this sequence of things? You're trying to calculate sum based on num1, and it's not defined yet. So you got to exchange the position of these 2 statements, right? I mean, this should be here, here, or here, not here. Okay. Now, if you use different values for these 3, 5, and 6, you get a different result, right? Now, whether you divide by 3.0 or 3, it doesn't make any difference because division always gives you a real number. So there's one small mistake in the coming slide somewhere. See if you can find it, or I will point it out to you. When dividing with 3, you get 4. Okay. What was it? 8 plus 6. 14. Okay. So this is wrong. This slide is wrong. When dividing, you always get 4.666. Okay. If I was doing integer division, then I would get 4. Okay. And that wasn't the case here. I used a single slash. Had I used 2 slashes, then I get 4. Any questions on that? Okay, so just be careful. There are some mistakes in the slides and possibly in the book. I'll skip this self-check and answer. Okay. Here again is a very simple problem. Calculate the square of a number, calculate the cube of a number, and print them both out. So again, this should be replaced with an input statement to be more general, to make the program more general. Otherwise, it works only for 4, right? Nothing else. And the square of 4 is calculated by doing this on the right side first, then assigning the result to square. Then doing this on the right side, assigning the result to cube. Use 2 different identifiers. These are called identifiers. And we'll learn a little bit more about them in the following chapters. And make them meaningful. Does it make sense to have num, square, and cube, etc.? It's more meaningful than I use x1, x2, x3, or xyz, or something like that, right? And does it make any difference, this pseudocode, does it make any difference if I put parentheses or not? No. We don't run pseudocode on any computer. It's for communication between people. Any questions on that? Okay. So that's the flowchart, exactly the same. You can easily write the structured flowchart also, and that's the program. In the program, you do need the parentheses for Python 3.0 and above. Otherwise, it gives you a syntax error. I'll skip the conclusion, and I think I'll stop here because we covered 3 chapters. Now I know I went through these in a hurry, but I'll slow down a little bit. Normally I cover 1 chapter a week, but because first week I was doing all sorts of examples, visual logic, etc., and we have basically covered all the material, right? So I'll try and do 4 or 5 or maybe both together next time. But then beyond that, I'll go 1 chapter at a time. Okay? But please keep up with the book. Read the book, do some of the exercises, ask questions, etc. So I'm going to stop here. You can continue with your assignment, or if you want to leave, that's fine. So if you're done with the homework, you can turn it in.
Well, when we turn it on.